video is about adding and subtracting rational expressions. Let's start by reviewing how you would add or subtract a normal fraction. So for example, 2/3 minus 1/5. We need a common denominator to do subtraction, which means this one will have to get multiplied by 5. And whatever you do to the denominator, you do to the numerator. The other fraction will have to get multiplied by 3, so that both denominators will be 15. This fraction becomes 10 over 15. This fraction becomes 3 over 15. And now we subtract. The numerator's 10 minus 3 is 7. The denominators are both 15. It stays as a 15. And you check your final answer to see if it can be simplified, which this one can't, so that would be the final answer. Let's try it with rational expressions. This slide, the denominators are the same. All you have to do is combine the numerators. So 7 plus 3 will be 10 over 4x. The denominator doesn't change. Check to see if you can simplify the fraction, which here you can. It will become 5 over 2x. That's the simplified version. Example B, subtraction. We can't do 2x minus 5, so we simply write 2x minus 5 over x plus 6. Denominator hasn't changed. We see if we can simplify this. Since nothing can be factored, we're not going to be able to cancel anything out. That's the simplified answer. What if the denominators are not the same? Okay, so in this first example, the first denominator is 4x, the other denominator is 7. This one needs to get a 7 multiplied by it, and this one needs to get a 4x multiplied by it, right? Whatever we do to the denominator, we'll do to the numerator of that same fraction. So this gets multiplied by 7 on top, and this gets multiplied by 4x on top. Now the fractions are about to become more complicated, but that's what you have to do so that you can subtract or add fractions together. The numerator of the first fraction is becoming a 21, 7 times 3. The denominator is becoming a 28x. The second fraction, the numerator is becoming a 4x, and the denominator is becoming a 28x. Now that both denominators are the same, we can subtract straight across the top. 21 minus 4x over, denominator stays the same, so 28x. Then we just look to see if we can simplify the fraction. If there's anything we can factor out on the top, we would have to do that. But there is nothing that comes out of a 21 and a 4. So this is going to be as simple as it gets. Let's try this example here. Right now, the first fraction, I'm going to leave it as it is. But the second fraction, I would like to factor that denominator. Because you'll observe something here. When you factor this denominator by taking out a 3x, you'll be left with x. Okay, so you'll be left with a 3x minus 4. Right? Double check that if you're not sure where I got that from. Took a 3x out of a 9x squared and a minus 12x. Now I look at these two denominators that I have. I need them to be the same. So I know that this first fraction needs to get this 3x minus 4 multiplied by it, right? So that it will get closer to matching the second one. But the second one, then, will not have the x squared that the first guy has. It has a 3x, but it needs to have a 3x squared. So what do I need to do? I need to multiply it by another x. Whatever you do in the denominators of these fractions, you do in their numerators. And then rewrite your fractions. I know that they're becoming more complicated, but that's what we have to do. So the first numerator is going to become a 1 times 3x minus 4, which is just 3x minus 4, over, now my denominator, I'm not going to distribute this. I'm just going to write them side by side. I have a 3x squared that was already there, and I have a 3x minus 4 that I'm trying to put onto it. The other fraction, the numerator is becoming x times x, which is x squared. And the denominator, I want it to match the first one. So I'm going to take this x multiplied by 3x, it'll be 3x squared. And it already had the 3x minus 4 on it. And as you can see now, the denominators are the same. So I can successfully add these fractions together now by putting the numerators together. Since there's nothing I can combine on the top, there's no like terms, I'm just going to write this in standard form. I have x squared is going to come first. I'm going to add to that a 3x minus 4. On the denominator, I have 3x squared and I have 3x minus 4. You don't need to distribute that on the bottom. Just to double check at the end, you should be able to factor the top. Well, sometimes you'll be able to, sometimes you won't. But if you can, you must factor the top to see if it reduces the fraction at all. So the top, since it's factorable, we want to rewrite it as x plus 4, x minus 1. And the denominator still says 3x squared, 3x minus 4. We look at our top and bottom, nothing's going to cancel out, but it's better to leave our answer like this in factored form to show that we tried. Okay? And that's it. Let's try one of these. So, the denominators are not the same, but let's factor them both to see if there's anything about them, right, that they have in common. So we're going to factor both denominators. The numerator stays. Denominator we rewrite as x plus 2, x plus 2. This denominator we rewrite as x plus 2, x minus 2. Okay. They both share an x plus 2. What the first fraction needs, it needs the x minus 2. What the second fraction needs is another x plus 2, and now they match. Whatever you do to the denominator, you do to the numerator. And now we rewrite both fractions. So in the numerator, we do want to FOIL, we do want to distribute. We need to get the top to be all multiplied together. So we have x times x is going to be x squared. X times 1 is 1x. Minus 2x will be minus x. And then negative 2 times 1 is minus 2. There's my first numerator. My denominator, don't bother FOILing it. Just write them all side by side since we're going to end up having to factor it anyway. We'll leave it like this. The other numerator, all we're doing is distributing a 6, so it'll be 6x plus 12. Over, leave your denominator like this, in factored form. I want it to match the other one, so I'll write it in the same order even. Now, if you're wondering why do we have to FOIL on the top but not the bottom, it's so that we can do this next step. We now need to combine like terms in the numerator to make this become one fraction. We're ready to subtract in the numerator. The x squared has nothing to combine with. It stays as an x squared. We have a minus x, and we have a minus 6x over here. Remember that we're subtracting. So this becomes minus 7x. And then we have this minus 2, but we have a subtract 12, so that would become minus 14. I guarantee that's what you'll forget to do on a test. You'll forget that this is subtraction of the 12, and you'll add it. So be careful. You want to remember that it's minus 12. Whole fraction over the denominator, which doesn't change. And at the end, we have to check to see if we can reduce this fraction. So we're going to have to factor the numerator, if we can, find something that multiplies to make 14, negative 14, that adds up to negative 7. So the only factors of negative 14 are 1 and 14, or 2 and 7. No matter where I place the negatives, neither one of those is going to add up to negative 7. So I can leave my answer like this. This is as simple as it gets. Good luck.